Hello, geometry students. We are going to be tackling lesson 7.1 today on ratio and proportion. And so I want you to join me on page 357. And I will probably be spending a little bit more time on this lesson because it does involve a little bit of algebra. And as you know, we are going to really pick up the pace in reviewing our algebra. So we're going to get a little bit of that review in this lesson today. So I want you to join me on page, like I said, 357, and I want you to look at the very top, and we have a little snippet about a baseball player, Nomar Garciaparra. I'm not sure if that's how you say his name. The Boston Red Sox won the American League batting title for the second straight year with a batting average of .372. He was at bat 529 times and had 197 hits. So that batting average is calculated using a ratio. And I don't know what the year, it's at 2000. And so they show you how they set that up. And so the hits, it comes over, the number of hits he has comes over the number of times he was at bat. So if you ever wondered how they figure out that batting average, that's how they do it. And so then what they do is they divide 529 into 197. So the ratio is a comparison of a number, A and B, a non-zero number, and we use division for that. So there's three different ways that you can write this. And so notice, and for all practical purposes for the rest of the video, my fractions will just be a slash like this, A over B. The second way you can write it is with the colon, A to B, and then the last way you can write it is with the word to, A to B. So anytime you see that, you know you're going to have a ratio of something, and we all the time are looking at ratios. Your score on tests is a ratio. So if there were 100 points and you got 87 of them, that it's 87 to 100. If I had 90 points and you got 85 of them, it would be 85 over 90. That's how I figure out your percentage. So you would divide the 90 into 85 and your percentage would then come up. So that's how we get your scores. So let's take a look at some different kinds of ratios that we might see. And the first one is written with the colon, 60 centimeters to 200 centimeters. And what we are going to do, it says it can be written as a fraction, and then very simply we then start to work on the fraction. And we think of a number that can be divided into both of those. Well, 20 is the one they choose, and so 20 goes into 60 3 times, and it goes into 200 10 times. And so now it reads 3 to 10. Fraction is merely a ratio. And then here's the other one, 3 feet over 18 inches. Now you've got to notice something here. You're not always going to have the proper measurements to be able to have a true ratio. So you may have to do some measurement changing, manipulating. We did a lot of manipulation in in algebra. And so what we do, we have to either figure out how many feet 18 inches is. It would be 1.5. Or the easiest thing is to actually turn our feet into inches, and then we end up with two whole numbers. So if we do that, we know that there are 12 inches in a foot. 3 times 12 is 36, and then we have 18. That is still there. And what we want to do now is look for a number that can go into both. Well, the smart folks at the textbook company figured out that 18 can go into both. And it can go into 18 one time, it can go into 36 2 times. So this ratio is then read 2 to 1. Okay, we're always going to, in geometry, we're probably going to be doing a little bit more with line segments, perhaps measurements of triangles, things like that. So if you look here, we now have a line segment. So we've moved into the geometry world with this one. And it says in the diagram, AB to BC is 4:1. So let's look at that. AB, so this part of the big segment, is 4 times bigger than BC. So four parts to 1 part, if you want to look at it that way. But the whole thing together is 30, and we don't have a measurement here, so we don't have to worry about that. So what I can do is I can take AB plus BC, and I can add in the 30, but I've got to do something first. AB, I'm not going to just call it AB. I'm actually going to call this X and this X, but I'm going to put the ratios in front of them. So here's my first X, that's AB. Notice they kept it in red here. And I'm going to put a 4 in front of it for the 4:1. The BC is in blue. There's BC. I've replaced it with just one X. And I know that 4X plus 30 equals, or 4X plus X equals 30. Now, could I have kept the AB there? Sure, I could have put 4 in front of AB, but then it would have gotten really confusing with this. That's why we have to kind of go to an algebra mentality. All right, then I add my X's. You know how to do that. I'm going to end up with 5X equals 30. Then I divide 30 by 5, and I end up with X equals 6. Now, don't give me that answer. It didn't ask me for the value of X, so be really careful in what you're looking for. I want to know the value of AB, and I want to know the value of BC. So now I have to go back to my original ratio, and I have to do 4 times X, or 4 times 6 equals 24. That's what AB equals. And then just plain old X equals 6. BC is just going to equal 6. Adding them together gives me the original 30. So be very careful. I like to underline exactly what they want me to find. Here they said find AB and BC. So I would underline that. Okay, let's look at another one. And this one's a little bit more thinking that you're going to have to do. It says the perimeter of a rectangle is 80 feet. The ratio of the length to the width is 7:3. Find the length and width. Now we've got to remember some things about the rectangle, and we've got to remember some things about perimeter. Remember, we've dealt with perimeter and area before in algebra. Area is like if I'm going to buy carpet for my house. I need to measure one wall, pretend it's a rectangle, one wall and then another wall, and I need to do length times the width, and that's area. Perimeter, though, is like I'm putting a fence, and I need to know the exact measurement completely around the yard. And that is when I'm going to have length and length, adding those two together, width and width, adding those two together, that will give me my perimeter. Okay, so we got to remember all those things. So the ratio we know is 7:3. So again, I'm going to use X's. So I've put in X for the length, I'd put in X for the width, but I'm going to put my ratio in front of them, 7X and 3X. And then I know, sorry, my screen just wants to keep jumping here, and I'm not sure why. I have to remember that I have 2 lengths and 2 widths, and that's going to equal the perimeter. So now I come down here to 2 times 7X plus 2 times 3X, and I know my total is 80. They told me that somewhere. Where did they tell me that? Oh, up here, right up here. So equals 80. Then I start working with my X's, 14X plus 6X, and I'm going to have 20X equals 80X equals 4. Is that what they asked me for? No, they didn't ask for X. They said to find the length and the width. Now I have to go back to my original 7X, so 7 times 4 is 28, and 3 times 4 is 12. That's the answer I want to provide. So on a test, if you only tell me that x equals whatever it equals, you're not going to get the credit for that problem. You need to go back and then kind of look at your diagram again and figure out. I always say mark everything. Give me everything. It's better to have too much than not enough. All right. I have a couple checkpoints here that I want you to try. And the first one, they give us the answer, but I'm just going to talk through them. So in number 1, it says in the diagram EF to FG is 2 parts to 1 part. EG, the whole thing, equals 24. So what we need to do down here is I'm going to have X represent FG, 2X represents EF. And that's because EF to FG is 2 to 1. Therefore, 2X plus X equals 24. So this is the 2X plus the X equals 24. Then I'm going to add my X's together. I'm going to have 3X equals 24. And X is going to, put a plus sign there. Let me change that. X equals 8. And so then we go back to our 2 to 1. 2 times 8 is 16. And FG is just 8. Then in the next one, the perimeter of a rectangle, and they don't give us a picture here for this one. The perimeter of a rectangle is 84 feet. Just remember our rectangle from right before that. The ratio of the length to the width is 4 to 3. So in number 2, length, so one side of my rectangle, envision it, is 4x. The width is 3x. But how many lengths do I have? I have 2. How many widths do I have? I have 2. So 2 times 4x and 2 times 3x is going to equal the 84 that they give me up here. I do all the math. 8x plus 6x is going to be 14x. I figure out that x equals 6. But then I have to go back. 4 times the 6 is 24. 3 times the 6 is 18. So hopefully you have that down. If you don't, make sure we go over it again in class. So just ask me on Wednesday. All right, if you look at the top of page 359, solving proportions, and this is just fractions, guys. It's just all fractions again. 2 ratios when they are equal. So here's one ratio right here. Here's the other ratio. We've got them equal to each other. Is called a proportion. So 2 ratios together, you're going to have to answer that on a test, I'm sure. 2 ratios together is called a proportion. Now, they've given us all kinds of numbers here. A over B, C over D. 2 ratios. The numbers B and C, bottom number on the left, top number on the right, are the means. The extremes is the top number on the left, bottom number on the right. Those are the extremes. And the reason they've colored them for us is because we can multiply the B times the C and the A times the D. Remember cross multiplying? You've seen that? Well, this is called cross product property. It's a big mouthful. Cross product property. And I thought I had, yep, there it is. So in a proportion, the product of the extremes is equal to the product of the means. Okay, so let's see what this is going to look like. All right, so let's look at this. We have 5 over 3, and we know it equals y plus 2 over 6. And we saw things like this in algebra, didn't we? So we set them equal to each other. They've already done that for us, and we're just going to multiply together the color-coded numbers. So we are going to have 5 times 6, there's the first color code, blue, and 3, and let's set this to, put parentheses so that we can set it side by side. Then I'm going to distribute. Remember that property? 3 times y, 3 times 2. Then I get 30 equals 3y plus 6. Then I start doing all my magic and manipulation, and I'm left with 24 equals 3y. Hopefully we remember. Remember we subtract 6 from both sides? Then we are going to have to get rid of that 3 in front of the y, because we can't have a number in front of the y. We divide by 3, we divide by 3, and we are left with y equals 8. Then we can actually go back and pop that into our equation. So here's the y. We put the 8 in. I end up with 8 plus 2 equals 10 over 6. My proportion is 5. 10 over 6 equals 5 over 3. So we know how to do that. Let me just remind you of this again. Cross product property, CPP. You can put those initials in a proof if we needed it. All right, let's do a couple of checkpoints here. I've done them for us, but take a look at them. Remember 3 over x, I know it doesn't look like a fraction, but it is how you write a fraction if you're typing on your computer. 3 over x equals 6 over 8. So I know it's kind of hard to see on here, but look at your book at the bottom of page 359. If we multiply the 3 times the 8, we have 24. And if we multiply the 6 times the x, we have 6x equals 24, and x equals 4. And you could go back and check these if you wanted. Over here, 5 over 3 equals 15 over y. And if you look at your book, 5 times the y, we're going to have 5y equals 3 times 15, which is 45. We divide each side by 5, and we are left with y equals 9. Then, the last one, we have m plus 2 over 5 equals 14 over 10. So we're going to do the same thing as we did in the previous problem. 10 times m plus 2 is what we have when we multiply those two together, equals 70. We distribute it, and we end up with 10m plus 20 equals 70. Then we subtract 20, we're left with 10m equals 50, and m equals 5. So there's a lot of information in this one little chapter. I don't think anything in and of itself is that difficult, but we are getting some algebra back into kind of our regular living geometry days. So if you are stuck on these things, then you need to ask me to slow down on Wednesday and go over some of these basic algebra principles, because if you lose that, then you're going to get frustrated for the rest of the year with our geometry, because we are going to be doing some regular algebra review, but then there's also going to be algebra in our geometry lessons. So make sure you know, ask for extra help, start coming to the office hours on Thursday so that you can make sure that you keep up with all that we're doing. I will see you on Wednesday.